Hey guys, it's Miss Rainey. Today we're going to be doing a little bit extra. Some mole conversions. We're going to convert from moles to grams, grams to moles, moles to atoms, atoms to grams, atoms to moles, and so on and so forth. Are you ready to get started? Let's go. So let's start with how many grams are in 4.5 moles of aluminum. So this is a conversion problem, and in a conversion problem we need to use factor label. That's right, factor label. It's awesome. So we're going to start first of all with the number they give us. That's the 4.5 moles. First thing we want to write is the 4.5 moles. Factor label has a times sign and a line, and the unit at the beginning goes down at the bottom. And the unit we're looking for, which in this case is grams, is going to go at the top. That's your automatic every time for any factor label problem, is to start with what they give you, put that unit on the bottom, and put the unit you're looking for on the top. Now we need to figure out what numbers go in between. Remember that moles always gets the 1, because moles is always going to be the bigger unit in anything having to do with anything else. So now we're going to look at aluminum, aluminum on a periodic table. It looks like it's 26.98 grams. So my calculation is going to be 4.5 times 26.98 divided by 1 equals 121.41 grams. Rounded to two significant figures is 120 grams of aluminum. Let's do another one. Now we've got how many moles are in 166 grams of cesium. Again, we start with the number that they give us, 166 grams. Times sign and a line, and that grams goes on the bottom. This time we're looking for moles, so moles goes on the top. Moles will always get the 1. Moles will always be the bigger unit, and grams comes off of the periodic table. So when I look up cesium on the periodic table, it says that its mass is 132.9 grams. So we have 166 times 1 divided by 132.9. And that equals 1.249 moles. Rounded to three significant figures is 1.25 moles of cesium. All right, let's try one more. In this one, I want you to pause the video now, work this problem on your own, and then play the video and see if you got the right answer. So pause your video now. Okay, I hope you paused it. All right, how many atoms are in 7 grams of krypton gas? So we're starting with the 7 grams. Times sign and a line, grams on the bottom, atoms on the top. Remember that grams are always going to come off the periodic table, in this case for krypton. So krypton is 83.80 grams. Now it's a little tricky in this case because I want to go straight from grams to atoms. So it might be easier, instead of going straight from grams to atoms, to instead go from grams to moles, and then do another step and go from moles to atoms. Sometimes moles is easier to fill in your math with, because moles is always going to get the 1. And so 1 mole has a mass of 83.8 grams, but 1 mole also contains 6.02 times 10 to the 23rd atoms. If you want to, you can skip out this step and just put the 6.02 there as the top. That would work just fine. It actually does the same thing, but if having the moles in there makes it make more sense to you, that's fine too. So we'll have 7.00 grams times 1 times 6.02 times 10 to the 23rd divided by 83.8 grams divided by 1 equals 5.03 times 10 to the 22nd atoms. All right, that was pretty awesome. Let's do another one of the same type. So for this one, I want you to pause the video now, work this problem on your own, and then unpause and see if you got it right. Pause your video. All right, I can just hope that you did. We're going to start with 1.8 times 10 to the 24 atoms. 1.8 times 10 to the 24 atoms. Times sign in a line, atoms on the bottom, grams on top. Atoms is always going to get 6.02 times 10 to the 23rd. And then grams is always going to come off the periodic table. So you can, if you would like, change it and put moles on top here, and then moles back to grams. In that case, moles would get the 1 in both places, and grams is going to get phosphorus, which is 30.97. Or you could set it up with one step instead of two. 1.8 times 10 to the 24 atoms. 6.02 times 10 to the 23rd atoms is 1 mole. And 30.97 grams is 1 mole. So that those two things really do equal each other. Either way, you solve it with the top or the bottom, it'll be the same thing. So we'll have 1.8 times 10 to the 24 times 1 times 30.97 divided by 6.02 times 10 to the 23rd divided by 1 gives you 92.6 grams of phosphorus. And there you go. I hope those little mole conversions kind of sprung something in your memory and you know how to do them. Y'all have a good day.